Ooh. Hey guys, today we're talking about molarity. So, molarity is the amount of moles of solute per liters of solution. So remember, solute is going to be what is being dissolved. Per liters of a solution. So here's some keys. Capital M is when we're talking about molarity, okay? 1,000 milliliters is always going to equal 1 liter. You always use liters, okay? Always, always, always. So if your problem is given to you in milliliters, you are going to convert it to liters. Moles, we've talked about this already. So if you are given grams, make sure you use the molar mass, which is going to be capital MM, in order to convert. So remember, if you are given grams of a number, set up your T-chart. The molar mass is going to be at the bottom, and this is always going to equal 1 mole. If they give it to you in gram, oh, we just said that. But if your answer is looking for grams and they give you mole, remember your number of moles is going to be up here. You set up your T-chart. This is also going to be moles because you need to divide it, and this is going to be grams. For both of these, you're going to use the molar mass in order to solve for it. Okay, so let's look at the first example. It says there is 2.9 liter solution of sodium hydroxide with 15 moles of solute. What is the molarity of the solution? What you're going to do is, I always like to write my equation. It's also provided for you up here. So M is going to equal moles over liters. They tell you, they give you 2.9 liters, so that's going to be down at the bottom, and 15 moles. Okay, moles, this is liters. Okay, and then you just divide. That is how you solve molarity. I don't have a calculator right in front of me. Give me 1 second, I'll go get one. Are we even surprised that I forgot a calculator for this? No, we're not. Okay, so 15 divided by 2.9 is going to give us 5.17. For your answers, always round to the second decimal place. So actually, we'll do it 1 decimal place. So we will do 5.2 molarity. Always write the substance as well. So it's going to have a 5.2 molarity of sodium hydroxide, which is NaOH. Okay. The next problem says find the number of moles in a 2.7 molar solution of NaOH if the volume is 15 liters. So I write my equation just like always. Molarity is going to equal moles over liters. Plug in the information that you know. 2.7 M is going to equal, they don't give me moles, over 15 liters. Okay? And in order to solve for it, you're just going to multiply this by this. The reason why you do that is because since this is at the bottom, you need to get dividing, you need to get rid of it by multiplying. So you multiply 15 liters on this side, that will cancel with this, and then what you do on one side, you do to the other. So 2.7 times 15 liters is going to equal 2.7 times 15, 40.5 moles, okay, of NaOH, right? Now for the last one, it said find the number of grams in a 2.7 molar solution of NaOH if the volume is 15 liters. So this problem is exactly the same as this problem. So I'm going to skip the step that got us here, okay? But if you didn't have example 2, you would do the exact same thing. You would plug in the information you know, you would solve for the number of moles, okay? So we got 40.5 moles in this original problem, and now we gotta get it to grams. So this is NaOH. Now we're gonna convert it to grams. 40.5 moles of NaOH. Moles is up top, so you know 1 mole is going to be at the bottom. Ooh, this is always 1 mole, okay, of NaOH. Up here, you know it's going to be grams because that's what you're trying to get to. And for here, you're going to use the molar mass. Sodium, Na, has a molar mass of 23. Oxygen has a mass of 16, and hydrogen has a mass of 1. You're going to grab these numbers from your periodic table. Okay? So, we add this up. 23 plus 1 is going to give me 24. Plus 16 is going to give me 40. So this is going to be 40 grams. So in order to get your answer, you're going to do 40.5 times 40, and that will equal 1,620 grams of NaOH. Okay? And that's how we got there. Let me know if you have any questions.